This presentation will be going over a few of the different data outputs that the Particle Insight has. The Particle Insight is a particle shape analyzer that works in very high speed and can actually give you an enormous amount of information. We have up to 30 different shape measures. So for every particle that is measured in real time, we calculate up to 30 different shape measures and update statistical histograms in real time, and keep a thumbnail of the image. So it's a very high-speed instrument, and it works very quickly with the analysis. But obviously, one of the things we need to do is to output the data. So we'll be reviewing the different data outputs to the Particle Insight. With respect to data outputs, there are two different types that we're going to be looking at, and we'll try to do them briefly here and go into more detail in other presentations. But the two data outputs that we're going to, data types of outputs, were the ones that are going to be viewed within the software and the ones that are going to be viewed outside the software. So with respect to the ones that are going to be reviewed within the software, those are the ones that are more typically the statistical histograms and the different ways within the software to show the results. The ones that are more externally based, those are the ones that are the Excel type outputs and different data outputs that any user can select to view at their leisure with Excel if they're more comfortable that way. But all the data is available for viewing within the Particle Insight software. For statistics, we have two types. We have the small data windows and the large data windows. They're both very similar, but we're going to be going over the different types of statistics that you can actually generate for each one. We have, once again, up to 30 different shape measures that are generated for one analysis, and it's all done in real time. We also have what are called sample overlays or multiple run summaries, where you actually can overlay sample results. This is very useful because if you have particles that may look the same, if you assume they're round, assume they're spherical or circular, they may have a very different shape. They may have different smoothnesses, circularities, and that's where you can actually determine the difference of, let's say, a sample this month from a specific lot to one from a different lot 3 months ago. You can actually do an overlay and see if there's any change with respect to shape, not just size. We also have the ability of doing what's called correlation plots. Correlation plots allows the user for any sample to overlay, do a correlation of any two shape measures. So let's say you're interested in seeing if your particles, as they're getting bigger, are they getting rounder. You can actually do an overlay, a correlation plot, and you can actually look for any specific areas of interest. Let's say in this case we wanted to find out what all these particles were in this region. We can go in and we can selectively just go look at the thumbnails, images of just these particles. So this is the correlation capabilities. With respect to outputs that are outside of the Particle Insight, once again, we have an enormous amount of information. Once again, for every particle, we have up to 30 different shape measures. We have different types of Excel reports. We have Excel reports that are generated that are very basic, where you go into the overall summary of the sample, and then for every shape measure, we have a tab. We have a few other ones which we'll go over. And then lastly, with respect to just the actual software from the desktop, we have printed reports. The printed reports can be customized. They can have histograms, they can have tabular data, they can have thumbnails as well, and that can all be set up and locked down for any specific reporting feature. One other feature that we have outside of the Particle Insight software for reporting is the iPad application. So we have an iPad app. So if you have an iPad, you can actually go in, and with the iPad app, you can actually have the Particle Insight, when it's done with its analysis, automatically upload all the data to a secure cloud server. And then if you have the iPad app and you're signed in for that specific Particle Insight, you can actually download the data. This is not just a data download. Basically, you're going to be downloading the data. You can actually do some analysis. So for example, let's say on your iPad, you had somebody on the other side of the world run a sample. It's automatically downloaded to your iPad. You want to go in and say, well, I want to find out how many particles, equivalent circular area diameter, how many particles that I have greater than 100 microns. You can actually To do that, you can actually put your finger on 100 microns, drag it over, and it'll actually automatically calculate, tell you exactly how many there were, what the size of those were in mean, the standard deviation, and all the different statistics. So it's the first company to have a iPad app for particle size and shape, and it's very unique and it's very useful. So at this point, what we'll do is we'll go in and start looking at the actual particle insight. With the particle insight, we can. What I'm going to do is we can open many different shape measures. I opened a particle insight demonstration file that comes default with the software. For this presentation, not to make it too long, I can go in and just pull out one shape measure. So let's say we want to look at circularity. So when we look at circularity, we can actually get a result for circularity, and we can see not only the small data window, we can actually expand it here, and we can look at the count. We can look at all the different information. We can look at the same thing. Let's look at size because this is a very interesting sample. We can actually look at size by number, surface area, and volume, and we can go in and look to see what the results look like. We could look to see how many particles we had and what the mean was. I think we were playing around with a sample earlier, so let me just reopen it, and that looks about better. Okay, so we were eliminating some particles on earlier, but this sample basically is made up of two different samples. It's some kind of a garnet sample and some polystyrene latex. All the statistics are available here, can be modified in the report options. We can actually display your D10, D50, D90, or any other statistical value, percentile value. We can actually look at the data by number, volume, and surface area. We can actually put a cumulative line or not. But then now, one of the outputs that we have for reports, well, obviously you can print this. You can print this information, but in addition to printing, you can actually just send everything to a WMF format. And by sending that to a WMF format, it'll actually create a file which will actually show up and is good for, let's say, sample reports. If you actually want to report and you wanted to show what your results were for this specific sample, it'll actually create a screen capture just of this window. Maybe it'll look better if we do it for circularity. We can do the same thing for circularity, where we could go in and we can say, okay, well, show me the WMF file. Go into our export directory, and we should have a circularity file that actually shows up. This is useful. It doesn't have any statistics built into it. Some people like to use this. Some people actually just like to print this single screen. We also have the ability of going into what's called the large window display. The large window display, this is a circularity measure. It's not by surface area or by volume. You can look at the cumulative. We go into more details on how to do the report, the analysis. But basically, if we look at the statistics, this will be the statistics of the entire range, exactly how many particles it found. You can actually look at the sub range. You could say, let's say from 0.5 to 0.7. I wanted to know what these particles and how many there are. You could say, well, there's 5,510 particles in that range, and represents about 37% of the distribution. You can print here. It'll print the entire plot plus this data. You could do a screen capture right here. Sometimes what I find useful is not only to look at the histogram, let's say, of the area of choice from about 0.5 to 0.7. You can actually print this, and then you can actually also go in and use what's called the thumbnails. Thumbnails are very useful, and you can say, well, I only wanted to see the particles that have a circularity of about 0.5 to 0.7, and you can actually see every single particle. Now, if I don't set the limit, I will see all 15,000 particles. But since I set a limit and I want to see the value under each particle to be the circularity, I can go in and look at the thumbnails. So if this is a region of particles that is of interest to you, and you wanted to show somebody not only the graph but the thumbnails, you can go in and you can actually take one screen here, and you can print an individual screen, an individual image, which is this entire screen. Now, let's say that's good for a report that you may want to generate. However, one thing you may want to do is print all the thumbnails, or just print the thumbnails that are from 0.5 to 0.7. Well, being that I had already set a limit of 0.5 to 0.7, if I were to go ahead and press print here, it would print a report based on report options. It would print a report, and it would go through all the different formats. It would write my run information. I could put whatever information I want. I could put my circularity. I want a maximum of 10,000 thumbnails, but I don't want it to be more than 10 pages, and I want the background to be very bright. I could use my logo. I could put the system data or not. I can say I'm only interested in seeing size, circularity, and smoothness, let's say. I could look at all the different graph options by number, by volume. And then at that point, I can go ahead and just hit print. And it'll print all the statistics that the statistical histograms, but with the data under it, but it'll only print the thumbnails of the particles that I was interested in. In this case, it will only print the thumbnails from 0.5 to 0.7, which are the only ones that I was interested in. So those are the two main functions for a large data window and a small data window. How to report the data either by screen capture or by doing a physical report just of the data that you're interested in. If you want all the data, you just select every measure, and it becomes a little bit overwhelming, but sometimes it's just better to show just the portions that you're interested in. Okay, besides the large and small data windows, we also have something that's called a table. Table allows us to go in and look at the tabular data, all channelized. For example, in this case, this sample we had from 3.97 to 4.08 microns, we had 4 particles. We could look at the cumulative percentiles. We can actually have all these columns sortable. And of course, we can print this as well. That's something that's useful. In addition to tables, we already went through thumbnails, but we also have what's called multiple run summaries. That's another data output. Multiple run summaries are basically overlays of different samples. In this case, let's just pick up 2 random samples here, and it's a particle insight demonstration file and a glitter flake. When we look at this, we can actually look at their, let's say, their circularity, their mean, the average circularity by number, and we can see that maybe their circularity was kind of similar. So you would think that their circularity of 0.7 for the glitter flakes, circularity of about 0.7 and close to 0.79 for the glitter flakes. You would think that these samples are very similar in circularity, but when you actually do an overlay, you can obviously see that even though the average is similar, they're very different. And this is where these plots come into play. Very interesting and very useful. Once again, you can print it, and when you print it, it'll actually ask you for a comment. A comment box will open up after I press print, where you can go in, you can actually type a comment, and you can make any comment you'd like to, so a coworker could see it and just look at one area of this plot. You could do this for every shape measure that's been selected. You can print it out and do the overlays by number, by volume, depending on the shape measure. There is another feature here which we'll be going into detail in another presentation, but basically you could create a worksheet right off of here. You can actually create all the shape measures that you're interested in. Even though you captured a lot of them, you may not be interested in all of them. You may only be interested in, let's say, size, circularity, and smoothness. And you're only interested in the mean, the standard deviation, and the different percentiles. You hit OK, and then you actually will create a worksheet. So when you create this worksheet, it'll create a run series worksheet, which will allow you to, I think I replaced that, which will allow you to just, I think it was Glitter Flakes run series, was it? And it'll allow you to just have the statistics that you selected. And obviously here we only had 2 samples that we're comparing one to the other, but you can have instances where you can have hundreds of samples, and you can have all their means, all their standard deviations. And this is very useful if you want to do any kind of time-stamped analysis, how particles are dissolving over time or growing over time. It's pretty useful. So multiple run summaries, that's another way of having some data output. We're going to go ahead and now migrate a little bit over to the external outputs. So some of the external outputs are generated a couple of different ways. So we can actually create a statistics summary file, which is under reports, and the statistics summary files is similar to the multiple run summaries, but it's for a single analysis. In this case, the glitter flakes. You can set the range that you want it for. You could set the statistics that you're interested in, and then you can actually create a file, and it'll create a SS file, statistics summary file. The statistics summary file is very simple, very basic. It'll actually create a file that just for that one sample will give you all the measures and all the statistics that you chose. So very simple. In addition to that, we can actually create an Excel file, an export, which is normally done at the end of an analysis automatically. This doesn't have any extension. It'll just save it as, let's say, Glitter Flakes Demo Sample 4. And when you open it, that's the one that we were looking at earlier in the presentation. We'll actually have on the first page, we'll have all the data generated with respect to the run statistics, the calibration information, things like that. And then under every tab, we'll have the count, let's say in this case, equivalent circular area diameter, all the different statistics, all the channelized data for every circularity, smoothness for every shape measure. So, and it's automatically calculated at the end of every analysis. In addition to that, one thing that it's also very useful sometimes is to look at what's called the that one doesn't have any particle thumbnails. Let's go ahead and open the demonstration file. We can go in. We can create what's called a particle text file. Particle text file basically is a file that will be created, and every line will represent one particle. So best way to show is basically just do it. We have a particle listing file because some versions of Excel only allow about 65,000 lines, which would mean that you can only run about 65,000 particles. In this case, we'll go ahead and run an Excel file. It will be a PD particle data file. We'll save it. Yes, let's replace it. Yes, let's overwrite it. And it created it. So if we look at the actual particle data file that we just created, we will find it, particle inside demonstration file is why I'm guessing this is it. So what we'll find here is we'll actually open up the raw data. Basically, it'll give you the information for the particle data. It'll tell you the frame. So this particle number 1 was found in frame number 1, and then it'll give you all the statistics for that one particle. This is for the second particle, the third particle, the fourth particle, the fifth particle. So it goes all the way down. In this case, it goes all the way down to about 15,100 and something. So very data intensive, but very useful. A lot of customers tend to really like using that. That's about it, basically. So the particle text file is very useful. We looked at the two different graphs. And without going into too much detail, that is the basic overview of how to do data output reporting from the Particle Insight. Internally, the graphs, the histograms, the tables, the correlation plots, the thumbnails, but then also externally with Excel. For the most part, most people use it internally with the thumbnails and the histograms, but the other features are important to talk about. Okay, so thank you very much for watching, and stay tuned for more videos.